We've been using lithium aluminum hydride on a lot of different things, but most of the time it's relevant to carbonyl containing molecules. We get alcohol. But why did amide give you amine? Why does it give you different things? So this is what I'm trying to show you. So for instance, you get aldehyde. Using lithium aluminum hydride, you know what happens? Hydride makes an attack, this goes up, makes O minus, which is going to pick up the proton, so you get alcohol. So you've seen carbonyl reacting with the lithium aluminum hydride, and then you get alcohol as a product. You do see that a lot. That's not only just ketones and aldehyde, ester is also alcohol, but it's using two hydride. The first hydride makes an attack, kick these alkoxy groups out, you get the aldehyde first, but that aldehyde is never going to be stable because we have so much hydrides hanging on. It gets reduced one more time, then you get the alcohol. So aldehyde is the primary alcohol. You have a ester, you get the primary alcohol. If you're using a carboxylic acid, same thing. The first reaction, first hydride is acid-base reaction. You've got H plus, H minus comes together. That makes a hydrogen gas. You really see the bubble coming up. So that's the first thing happen. That looks like the aluminum ester. So you look at the same situation as that. Second hydride makes an attack. It makes an aldehyde. And the third hydride is to reduce the aldehyde further up to the alcohol. So all of these carbonyl containing functional groups, aldehyde ketones, ester, carboxylic acid, even acid chloride, and most of them, it becomes a primary alcohol. Then the question is, why did amide not give a primary alcohol? What makes it different? So that is what I'm trying to show you here. So the difference is nitrogen and oxygen. That's the difference. Chemistry means, we've got different elements that we are reacting with. Each element has different properties, and that things how influencing the certain products. So the first step, the same thing. Hydride makes an attack to this carbonyl. These electrons goes up. We get this, tetrahedral. These intermediate shows are same as that one here, there, everywhere. The difference is we got nitrogen here. What happened was this nitrogen lone pair is going to coming in, making a double bonds, and kicking these groups out. So you get the imine ion forms first. That's a carbon nitrogen double bonds we talked about reducing by the hydride. So second hydride, reduce that, and you get the amine. Things are processed a different way is all because we have a nitrogen there. All other things don't have a nitrogen structure, right? So that's why that is not. But in the case of the amide, we got nitrogen here, so it stays, it kicks out this instead of the other side. Normally, these parts are kicked out, but nitrogen doesn't go that easy, so that's why it better kick the oxygens away. That's why you get the imine, and imine get reduced, so you get the amine. So this is where the chemistry really getting complicated, right? And then this is not the chemist who's key to do this. It's difficult. It's how the nature goes up. And then what the difference is, nitrogens are not really a good living. They don't want to go. I mean, there's alkoxy groups can go, these can go. I mean, that's not what that's the pH. It stays there. But the thing is, these nitrogens are not really bad living. It doesn't go. So it stays. But in the meantime, you make the double bonds by kicking these outside out. That can be reduced further, then you get that. So all of the carbonyl containing molecules give a primary alcohol. I mean the short what is shown here. We don't need to use a hydride. But if you're using the amide, you get the amine. So that's the differences.